You have undoubtedly bought something nice, opened the package, and saw some cool looking foam like this. I'd like to go over how to make that today. So let's get started by opening a new part. Now I'd like to jump on, let's say, the front plane and start a sketch and insert an equation-driven curve. Let's go with y equals the sine of x, and we'll go from 0 to 100. I'll take a few seconds to simply add a coincident and a fixed feature on this side. Let's make sure that equation doesn't walk around on us as much. I'm going to make a 3D sketch. This is completely optional. You can make a mathematical representation, but this is kind of a cheater way to get some planes to update properly should we ever change an aspect about this equation-driven curve in the future. So we're going to make sure that it's tangent and that we're coincident. There we go. Make sure that we're coincident here. Okay, now that we've played with it and we're fully defined, I'm going to add in one more, and we're going to select the midpoint and add in a midpoint relation, and we'll make this along Z. Finally, we'll set these to equal length. So that again is just a cheater way to get a fast update should our planes ever change. So let's make a new plane. Select this edge, and let's select the front plane as well. Now I can hide this sketch. It's done its purpose. We'll sketch on this plane and insert another equation-driven curve. Let's go with the cosine of x, and we'll call this 0 to 100 again. And notice it's not quite what we want, so we're going to say x plus pi divided by 2. That gives us the translation that we want. You can see we are now running basically the opposite curve, or an interference curve, as we might say. Okay, I'm going to do the same thing, but I have to be normal to select the origin on this sketch, it looks like, so make that coincident, and we'll fix this side. And that way it doesn't walk around. Let's hide this plane. So let's start by going to surfaces. We're going to say boundary surface from here to here. And now we have to make sure this will not work unless we specify normal to profile on both. Alright, now that we're normal to profile, I can choose the plane that I've just made, make sure it's highlighted, features, mirror, and we'll go to bodies to mirror, choose this body. It may not work if you mirror it as a feature. I'm going to change my graphics to shaded, and now I can say linear pattern, and I can choose a direction. For that, I will probably show my 3D sketch and choose that line. That's probably the easiest. I'll flip the direction, and let's see if I can remember. I'll say pi for distance, and for the bodies, we'll choose these bodies. Looks like we need to go a little bit higher, pi times 2. That looks pretty good. So spacing at pi times 2. Yeah, I'm on, I don't know if you can hear that, I'm actually traveling on business again, and I've got some noisy people outside of my room, so sorry if you can hear that. Let's hide this, and yeah, that's looking really good. So how do we make it solid is the question, and perhaps how do we make it pretty? If you want to make it pretty, I can simply, oh, it looks like it didn't pick up the lasso. I'm a little bit laggy because I'm recording my screen and have a bunch of hardware stuff going on. So highlight the whole thing. Under surfaces, we'll knit the surface. Now, of course, that didn't pick it up, so we'll lasso the thing again. There's our selections. And with a knitted surface, it gives us a lot of options. The easiest thing that we can do is thicken. Maybe I can thicken this to, I don't know, 0.3 or something like that. This is 0.4. Depending on your hardware, this may take a long time or a short time. And here we have a thickened surface. The problem is the underside is not, it's the same shape. So it doesn't look like the foam that comes in the containers. So I'm going to delete this thicken feature. Let's talk about something that's a little bit more realistic. I'm going to sketch on the top plane, and I'm going to choose a corner rectangle and just go from corner to corner on our feature. To avoid a zero thickness error, which could happen, let me try to extrude and see. Let's extrude and avoid a zero thickness by offsetting. Let's say we want to offset a distance of 2 inches in the other direction, and we'll blind it another 2 inches in the opposite direction. That seems like a reasonable piece of foam. Now the cool thing about surfacing is we can replace face. So I'll go back to surfacing, replace face, choose this face, choose my surface. I'll just choose surface knit right here on the history tree. And I'm going to hit check. And now we have a foam that is solid and shaped like how it comes out of the box. So solid all the way through. And if we want to make it pretty, which I think I was going to talk about, I can say appearances, part, and we can give it some kind of texture. Perhaps the closest one preloaded into SolidWorks is cloth, and I can choose gray cotton, and it has kind of that dark, nice foam color look. So that's how you can make a foam pattern pretty easily. I hope this video was helpful, and if it was, please subscribe. That's the best way to help me back, and I'll see you in the next video.